Ours is what is the purpose of network theory? Why we have to study this subject? And what are the entry points? In the sense, which kind of wings are there in network theory? And exit points. What are the boundaries of network theory? Because without knowing boundaries, if you enter into any subject, we will die like Abhimanyu. Because Abhimanyu didn't know how to come out of Padma Vyuha, right? So point here is purpose. Why we are learning this network theory? Okay. So if you see purpose of network theory, see here, our electrical systems will be there, right? Means everywhere it can be motor or generator or it can be transistor. Lot of electrical systems are there in front of us, right? So if I have, for example, one electrical system and with basics only we have to build, and a lot of students will have lots of doubts because of lack of proper basics. Basics are very, very important. Now, if I have one electrical system, for example, this is electrical system. In this electrical system, I would like to know terminal response characteristics. Okay. For example, of course, what is voltage, what is current in next sessions you are going to get from very basic level. And here, but for time being, let me use voltage and current. For example, if this is voltage and the current taken by this electrical system is this much. Now, for which level of voltage, which level of current flow, if I want to know, just like that. Okay, if I want to analyze the practically existing electrical system, okay, this is practically existing electrical system. For example, it's a motor, electrical motor. Now, if it is electrical motor, for given level of voltage, some level of voltage, how much current will my motor take? If you want to know what has to be done, directly take that electrical motor, directly apply that much amount of voltage and measure the current. No, okay, you can connect one voltmeter here and your required level of voltage you can apply and connect one ammeter here. Automatically you will come to know how much current it is going to take. Okay, or else let me tell you, if I think of if I think of BJT, for example, okay, if I think of one BJT, this is practically existing electrical system only. No? Now, if I want to analyze this BJT without knowing network theory and all, what we have to do? Directly, we have to take the transistor, and then means by connecting maybe ammeter here, okay, and by connecting one voltmeter here, and by connecting one ammeter here, okay, we can develop the characteristics. Maybe for one value of base current, for one value of VCE, how much is going to be the collector current, we will come to know. Directly, we can measure. Means directly after measuring, if you can draw the characteristics, automatically you will come to know about that particular device. No? Okay. Rather than that, while to learn network, these are all called as direct loading tests. Okay. In a practically existing system, electrical system, if you conduct direct loading tests, you need not learn network theory at all. You need not learn network theory. Okay. But for each and everything, can we do direct loading? For example, maybe BJT, if you think of BJT. Okay. If you think of 1 lakh BJTs are there, 1 lakh transistors are there in a chip, for example. If you want to test one BJT, okay, and then that particular BJT analysis can be applied to remaining 1 lakh minus 1 transistors, it's perfectly fine. Okay. For example, if I want to know how much maximum collector current, okay, any boundary conditions. If you want to know maximum collector current my transistor can withstand, if you want to know, what can you do? Means you can keep on increase collector current, and at one point of time, it will be fired. Okay. So transistor is going to be broken. Now, by that time, I'll come to know how much will be the maximum collector current taken by the transistor. We will come to know, isn't it or not? By direct loading. Now, that particular maximum collector current magnitude, we can apply to remaining 1 lakh minus 1 transistors. It's fine. Getting my point, right? So, point here is in direct loading, if I have multiple systems, same kind of multiple systems. For example, if I think of our motor, DC motor or induction motor or whatever it may be, so same type of motors, if I have in multiple numbers. Okay, what can be done? We can take one DC motor or some motor and we can conduct direct loading tests and we can apply those test analysis to remaining motors. But for example, in all cases, it may not be possible, right? If you think of big thing, for example, alternator, okay, AC alternator is damn big. The moment alternator is so big, can you dare to do direct loading tests of kind of what maximum speed it can rotate or what maximum current it can handle? Directly we cannot handle because it's crores of rupees. It's very big. So the moment it is very big, we cannot do direct loading tests. In an indirect way, if you can find the analysis of that particular alternator, it will be great. Okay. So what we are going to do is, what we are going to do is, rather than direct loading, we prefer indirect loading. That is nothing but network theory. Okay. In network theory, we are going, means if you want to analyze any electrical system for kind of indirect loading analysis, that is called as network theory. Okay. Now, in indirect loading, what we are going to do is, we are going to take physically existing electrical system. Okay, physically existing electrical system, kind of motor or generator, whatever it may be. So this is physically existing system. Okay, for this physically existing system, rather than directly applying, for example, I would like to know at one voltage level how much would be the current flow through that particular physically existing system. Okay, so for one voltage level, what is voltage current? We'll take care. Okay, ladder. Okay, current. For one level of voltage, how much would be the current? I would like to know. What we are going to do in network theory is, directly we don't apply. Direct loading test we are not going to do, because in all cases it is not possible. So what we are going to do is, we are going to convert this physically existing system into mathematical model. Okay, so the moment you convert this into mathematical model, okay, that mathematical model may contain resistors, inductors, capacitors, and different types of sources, dependent sources, independent sources. So whatever it may be, this mathematical model, okay, it will be created. Maybe if that mathematical model will contain resistors, will contain inductors, will contain capacitors, or will contain some different levels of sources also. And once physically existing system is converted into mathematical model, what we are going to do? We are going to apply KCL, KVL, mesh, nodal, theorems, transits, two ports, or whatever it may be. By applying those many things, for this voltage, how much would be the current? It is not the practical reality. Okay, because practically we are not applying that voltage or that current. Okay, so rather than applying to directly physically existing system, what we are going to do is, means we will convert into mathematical model. In that particular mathematical model only, we are going to apply different tools. What are those tools? Network theory. Okay, so we are going to apply different tools like mesh nodal, some kind of stuff. And by applying those tools for this level of voltage, how much would be the current? Indirectly, we are going to find without touching the physically existing system. Okay. Now you can make a note. Network theory or circuit theory, whatever it may be, it is meant to model mathematically physically existing electrical system. And once the mathematical model is done, upon that mathematical model, we are going to apply different tools. Okay. And by applying different tools, practically existing system, expected results, we are going to calculate from here. Getting my point, right? So here we are going to analyze and we are going to find out the conclusions without touching physically existing system. Okay. Now some people may think that how to convert it, for example, motor or generator. Okay. How to convert this into mathematical model? We are having different tests. Okay. Kind of we see open circuit test, short circuit test, block rotor test, so many tests will be there. By using those tests, okay, so by using those tests, we are going to convert physically existing system into mathematical model, and upon mathematical model only we are going to work out. And roughly we are going to estimate, it is not physically existing, okay? Roughly we are going to estimate the current for that particular voltage for this system. So basically network theory is kind of estimation, okay? It is not like real, because it is meant for indirect loading test, okay? Anyway, we know the purpose of network theory now. Purpose is over.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.